Hey guys, this is Jill with Let's Robot. I just wanted to give you a brief overview of the next robot that we were making while it still had all of its parts out, and just give you sort of a breakdown of all the different components that are going into our robots. So this is the new Tellybot that we were developing. This robot is going to E3 and is going to be babysitted by GameSpot. So hopefully it's going to be wandering around their war room while they're doing their coverage, and we may actually get to have it go out on the floor. So one of the things that's noticeably different about this robot right away is that it has a full pan tilt camera. So it can look up and down, and it can look left and right independently of its body. It's got the rest of the body is very much like the other Tellybots, except for like one more key difference is this robot has a drop suspension. So what this does is, well, it's not supposed to do that, but what it does is when the robot goes over something and then the ground gets lower, the drop suspension will drop the wheel down, and then the wheel still gets traction. So we're hoping that something like this will help us get over cords and stuff. So I'm gonna put this down right here and just leave it at that. So this robot isn't all super hooked up or anything yet, so it's pretty hollow. Battery goes here on the left and right side. There's a caster wheel. This is one of the power regulators I was using to sort of manually drive the robot with the most janky manual controller ever conceived by anyone, which is basically just a bunch of wires that I can change around that are just hooked up to the DC motors. So yeah, this robot also has kind of a nice front face panel, which is all made nice by our new mechanical engineering intern, Brian. He's super cool. Has a camera, has LEDs and all that stuff. One of the things that's very different about that's the air conditioning sound. I hope that's not too loud. One of the things that's different also about this robot is we're just using DC motors instead of continuous rotation. And those DC motors actually have full magnetic encoders on them, and I think I talked about encoders in the last video. So I wanted to talk about what was actually inside this particular robot, so you guys can sort of get a breakdown of the different components and how they work together. Let me just arrange this here. Alright, so when we turn this robot on, there's a single power switch right here, and this routes to 3 different power regulators. The reason I use different power regulators is to sort of have an independent powertrain for some of the robot systems. So the Raspberry Pi and the Wi-Fi, for instance, are on their own power bus with some of the sensors, because when the motors draw current, they tend to spike a lot. So it can cause brownouts on the Pi and on the Wi-Fi. I'm not an electrical engineer, so there's probably some better solutions to the problem, but what I did is the motors are basically on one power regulator, so voltage regulator. So this is a down voltage step down converter, and it runs at 2 or 3 amps, and if the motors are drawing a lot of amps, then the Pi won't have any amps, and then it'll brown out. So I have 3 of these things. So also because some systems run at different voltages, so the new DC motors, for instance, they run at 12 volts. The servos tend to run around 6 volts, and then the Pi and the Wi-Fi, they run at 5 volts. So there's 3 different power buses. So this is also a power regulator. It's a little fancier than the others. This is a custom board that I made. It is basically a few boards like hooked together. So this is a Teensy, and a Teensy is sort of like an Arduino, except it has a pretty small form factor. And I designed this board so some of these components, they can come on and off. So this is the IMU, so this gives you 3 degrees tilt, so you can get direction this way, and this way. It also has a 3-axis compass and a 3-axis accelerometer, so you can tell which direction you're going in each direction. So that's super useful. This is a motor driver, so this is for the DC motors. And this is also by Adafruit. And these are all hooked together with all of this wiring. I made a lot of my own custom connectors, so this one goes to the Pi, for instance, to the different pins that I need on the Pi. The Pi would go to the camera in the robot, and then we have a Wi-Fi card here. And this is actually a dual-band wireless bridge. It's by Netgear. I believe I have the box somewhere. Yeah, so this thing, it actually comes in this cool enclosure, and I've been using this box to sort of use as a base for drilling, so there's holes in it, but this is the one that we use because it's dual band, and so we get on the 5 gigahertz band, which when you're in a place like Berkeley is a lot less crowded, and like the 5 gigahertz bands tend to be a lot less crowded. The nice thing about this wireless bridge is it's USB powered, so we can just plug power into the USB and it works, and then we take a small Ethernet cable and run that into the Pi. So this actually gives us the most stable connection. And the other reason why we actually have an independent Wi-Fi card and we don't use a USB Wi-Fi on the Pi is because the way that the Linux kernel on the Pi actually handles like the internal Wi-Fi logic, it only indexes so many Wi-Fi access points in the area, and this is like ingrained somewhere in the hardware. So if you're in a place like we are with like a lot of access points, sometimes your particular internet access point will be out of range. And there's basically nothing you can do about it. It will just not exist. Like, you can see the name because it'll actually read all the names of all the access points. But as far as the Pi is concerned, like, you can't access it anymore. So it's actually like a big pain in the butt for us. So we have this independent card here that handles all of that Wi-Fi logic. So the Pi basically just has some basic software on it that interfaces with our command server, and that online server is what gets the commands from Twitch and sends them to the robot. So through the Pi, it just sends them to this Teensy, and this Teensy has all the low-level logic for the motors and the actuators and LEDs and all that other stuff. So maybe next time I can show you what this robot actually does when it's on, but I'm already running at nearly 9 minutes, so that's a pretty good video. Thanks, guys. Be sure to follow the channel, like or subscribe, leave comments, tell us how awesome we are. If there's anything you want me to know about, or you want to know about, just ask. I'm trying to do this more impromptu video format because it just takes a lot of time to make those very nice, more formal videos. But I'd rather just get the information out there rather than like spending too much time on presentation. Anyway, thanks.